Hey there, this is Mr. Wilford, and I just wanted to go through Chapter 4, Section 5 with you. This is all about matrix inverses and solving systems again. We are going to first start out talking about what a matrix inverse looks like here. And when you talk about a matrix inverse, what you're looking at really is this symbol here, a to the, it looks like to the power of -1. But that really is just representing the inverse of matrix A. And to determine whether you have two matrices that are inverses of each other or not, what you want to do is actually take the two matrices and multiply them together. And you can do this by hand, or you can use a graphing calculator or an online calculator to do that. When you multiply these two matrices, if the product is the identity matrix, then they are inverses of each other. Recall that the identity matrix is the matrix where you have ones in the diagonal and every other element there is 0. So these would be these two matrices would be inverses of each other. When you look at example B here and you multiply those two together, notice that you do not get the identity matrix. You do not have the ones in the diagonal and zeros everywhere else. So these are not inverses of each other. So basically, to determine whether two matrices are inverses or not, you need to be able to multiply those two matrices. If we look at the next page here, now to actually find an inverse of a matrix, what you need to do is use this formula right here. And this is an example of a 2 by 2 matrix. Here I have a 2 by 2 matrix A, B, C, D. And the inverse of that matrix would be 1 over the determinant of A, which, recall, a determinant of a matrix, that's where we take and we kind of do the crisscross thing, where we multiply A times D and we subtract B times C. So you're going to end up with a fraction here, 1 over the determinant of A. You're going to have a fraction, and then you're going to multiply that fraction by this matrix here. Now this looks kind of weird, but basically what's happening is you're switching the A and the D around, and you're changing the signs in the B and the C. So you create this new matrix. You take 1 over the determinant times that matrix there, and that would be the inverse of this matrix A. Here's an example where you can see this. I have matrix A here, and we find the determinant, which is 2. So we take 1 over 2, and then we flip-flop the -2 and the -4, and we change the signs in the 2 and the 3, and we get this new matrix. So we're taking 1/2 times each one of these elements to get this matrix here, and this would be our inverse of that matrix A. Next, what we want to do is talk about solving a system of linear equations again, and we've done this before using substitution or elimination. We can also do this with matrices, and this is where we take the coefficients of the x's and the y's and we put them together in a matrix called the coefficient matrix. We create a variable matrix, so x, y, those are our variables, and we set it equal to a constant matrix B, which is these numbers here, 8 and 1. And basically what you want to be able to do to solve for this variable matrix is multiply on the left side the inverse of matrix A. And that's what's going on here, and then you can actually solve for your variables. In this example here, it shows it's a pretty good example. Here are my linear systems, coefficient matrix, variable matrix, and the constant matrix. First thing you need to do is find the inverse of matrix A, and that is right here. Once you have that, you're going to multiply it on the left side on each side to get your x and y variables. So x is -7 and y is 15. Also be sure to check out the online matrix calculator. If you have any questions, please let me know. Thanks.